This is project number 19123, Facilities Related Control System Fire Alarm. Team Solar Systems, whose members' names are listed on the screen, were tasked by the sponsor Marine Corps Air Station Yuma with providing a design that met the requirements for upgrading their outdated and unreliable system for fire alarm signaling. This slide reflects the main topics to be covered in the presentation and the order that we will be going through them. The next 8 minutes will summarize our last 10 months of work. The Marine Corps Air Station Yuma Facilities Related Control System Fire Alarm is currently outdated and composed of insufficient reliable components. The desired end state of this project is a detailed inventory and technical description of the system as currently installed. An executable system levels architecture and components design for an upgraded and/or replacement system that meets the organization needs for reliability, security, maintainability, centralized monitoring, transition costs, and total cost of ownership. A final technical study report formatted in accordance with the sponsor-directed guidance and a simulation that illustrates the practical effect of improving the system. The functional flow block diagram illustrates the required functional components of the system and Solar Systems' vision of improving the communication of all buildings expected to be in service covered by the FRCSFA and monitored by the dispatch facility upon implementation of these improvements. MCAS Yuma requires a system that will reliably transmit signals from the fire alarm control panels at buildings on base to the dispatch facility monitoring said alarms. The current telephone network is insufficiently reliable. Cellular communication is not an option due to the signal security concerns per the primary stakeholder, and a fiber optic network is deployed throughout the base, which is stakeholders' preferred method of secure signaling. The images reflect the current system deployment for standard telephone monitoring as well as the envisioned method for signaling over the fiber optic network. Through applying the system engineering process, engaging the sponsor on a regular basis to obtain information, and by completing milestone meetings such as requirements verification review, preliminary design review, and concept design review. Ultimately, 3 courses of action were considered to satisfy the requirements of the sponsor and provide them with the recommended optimal solution. A final technical study report formatted in accordance with the sponsor-directed guidance and an arena simulation that illustrates the practical effects of improving the system. Among the courses of action selected were Course of Action Number 1, which considered independent fiber optic signaling from FACPs to dispatch, which had the advantage of utilizing existing fiber optic network owned by MCAS Yuma. This approach was deemed not to be optimal due to a lack of available commercial off-the-shelf fiber optic transceiver to implement a dispatch that would interface properly with monitoring software. Course of Action Number 2 considered the replacement of all upgradable FACPs to Honeywell Notifier. This course of action retained the advantage of implementing the fiber optic network owned by MCAS Yuma and resolved the lack of an available commercial off-the-shelf fiber optic transceiver by utilizing the media converter and IP receiver capable of establishing a reliable bidirectional fiber optic hybrid network capable of handling the required signaling and communications. This approach was deemed not to be optimal due to the fact that 18 FACPs were still under contract through different providers, and replacing them proved to be cost prohibitive for the project sponsor. Finally, course of action number 3 focused on independent fiber optic signaling from FACPs to dispatch using as much of the existing equipment as possible. Similar to the previous course of action, it resolves the lack of an available off-the-shelf fiber optic receiver by utilizing a media converter and IP receiver capable of establishing a reliable bidirectional fiber optic hybrid network capable of handling the required signaling and communications of the system. This course of action also retains the advantage of implementing the fiber optic network owned by MCAS Yuma for all facilities related control system fire alarm signals and communications, which allows all the signals to be transmitted over hardwired infrastructure on a physical secure Marine Corps air station which nowhere interacts with any infrastructure owned by or connected to a public utility or other outside entities. Ultimately, a trace study was conducted and course of action 3 was selected and approved for implementation at critical design review conducted with the project sponsor. This slide reflects the specific components to be implemented and their arrangement. Solar Systems' overall objective was the design of a system capable of increasing the life and safety protection capabilities at MCAS Yuma. To accomplish our objective, Solar Systems developed a systems architecture for a reliable fiber optic network, capable of transmitting data signals via single-mode fiber from the FACPs at 118 buildings located throughout MCAS to a central monitoring station and backup facility. The implementation of this vision of FRCSFA signaling begins at each building location. As authorized by a sponsor, 20 new fiber optic capable FACPs installations will be conducted to upgrade the conventional and obsolete FACPs. 98 existing addressable FACPs will be upgraded using a single mode fiber card with LC duplex connectors as recommended by the FACP model manufacturer listed in the respective technical manuals. As the signal transmission within our system is bidirectional, all operational monitoring devices connected to the new or upgraded FACPs will continue to be able to place the system in the required states. The transmission of all signals will travel through a 2-strand single-mode fiber optic wire to the SPF transceiver via LC connectors to the Cisco GLC LH-SM 1000 base LX LH SFP transceiver module attached to the front of the Cisco C9300 24S switch located at the communication server room. Then the Cisco C9300 24S switch will conduct an internal interface with the C9300NM8X, which serves as a fiber optic connectivity regulator, and the Cisco SFP10GLR attached to the C9300NM8X will establish a downlink signal with strength 10G prior to the signal transmission being connected to the existing MACS fiber optic network. Once the signal transmission exits the existing MTAS fiber optic network at the central monitoring station, it will travel along a 2-strand single-mode fiber optic wire to the Cisco SFP10GLR and the C9300NM8X. Then it will interface with the Cisco Catalyst 9300 24P and exit through the Cisco SFP10GLR components. These Cisco SFP's 10GLRs will be connected via LC connectors to the FlexPoint GXT media connector. It will convert the fiber optic signal into Ethernet signal and establish the Ethernet connectivity via RJ45 Cat7a cable for the Visor Alarm Plus IP receiver to complete the transmission of the signal to OnixWorks from the FACP at the building. OnixWorks software in conjunction with the Visor Alarm Plus IP receiver can be programmed to send monitoring signal transmissions to the FACPs to check a current system state. In this type of event, the signal transmission is sent via OnixWorks to the Visor Alarm Plus IP receiver as an Ethernet signal, then the FlexPoint GXT media connector converts the Ethernet signal to a fiber optic signal and flows the same flow in the reverse direction through the fiber network. An arena simulation was created to illustrate the practical effects of the system improvements to be undertaken. The major functions of the system, both before and after the completion of the system improvements, are simulated as processes. When run, it reflects that over the course of a year, a typical building could expect to see 11 instances where a false alarm was received and responded by emergency personnel, only to realize that a simple and unresolvable communications error was to blame before system improvements. After system improvements, the simulation reflects that a similar issue will occur at most once a year. The simulation was tested via logical walkthrough, repeated tests under varied and extreme conditions, and analyzed for accuracy versus the evidence provided by the sponsor. Cost estimates were prepared for all 3 courses of action and were presented in the final report in a format consistent with guidance provided by the sponsor. Examples are reflected in the cost per building estimate, the selected course of action overall estimate, and on the next slide, the master file is reflected. This contains and reflects the choices made regarding what components are implemented, in which course of action 3 met our criteria. Thank you for viewing this presentation by Team Solar Systems, and we look forward to meeting and addressing any questions you may have at our future meeting via Zoom.